Welcome back. Electronegativity down there can be described as the tendency of an atom to attract electrons that are being shared. So let's use the example C, hydrogen and fluorine, because fluorine is the most electronegative. By the way, if you do some calculations, you get this most widely used scale called the Pauling scale. So you get these values which assign an electronegativity value to each element. So the higher the number, the more it has an attraction for shared electrons. So hydrogen being 2.1 and fluorine being 4.0, so they have a difference in electronegativity of 1.9. And oftentimes we'll use the Greek symbol chi to denote electronegativity, and so the difference is delta chi. Delta is the capital delta in the Greek alphabet. Okay, so what that means is if we have a hydrogen atom there coming in with one valence electron and fluorine coming in with 7 valence electrons, they would both like to gain one more electron to complete their orbitals. Or hydrogen only having a 1s orbital only needs one more, and fluorine having 5 electrons in its p orbitals would like to have one more to complete that. Okay, so these two electrons are being shared. However, it's not, in this case, being shared equally. Because fluorine has a much more tendency to attract those electrons, more of those electrons are going to reside on fluorine's side. So fluorine's side is going to have a greater electron density, and so we use the lowercase delta, Greek symbol delta, to denote a partial charge, not a full ionic transfer of electrons, but just a partial charge. And that side is going to be partially negative because it's going to have a greater electron density, and the hydrogen side is going to be slightly positive. Let's get that away a little bit more from the... Alright, so that's how we're going to denote that. So this is called a polar molecule. This is called a whole polar bond because the bond is not equally shared, but it also happens to be a polar molecule because it only has that one bond. Okay, so let's, the first thing we need to do is, or we can do, is just get the delta chi's, or the differences in electronegativity. Then we can arrange them from the greatest to least. Now the least is going to be the hydrogen-hydrogen covalent bond, because when two atoms of the same element are sharing electrons, they have the same electronegativity. Therefore, there is no difference in electronegativity. All right. And by the way, this is your covalent bond. I think you knew that. All right. Hydrogen chlorine is going to be a difference. Let's use our table. All right. 2.1 is hydrogen for all of these except for F. All right. Chlorine is down here. So the difference is 0.9. So that's going to be a polar bond. All right. Hydrogen carbon. Carbon is right in the middle. 2.5, 2.1 is 0.4. So nonpolar, you can consider that. Hydrogen is the second most electronegative, next to fluorine being the most. So that's definitely going to be polar. Right, that's, water is made of H2O. It's a polar molecule. You knew that, sure. All right, 3.5 minus 2.1. It's going to be 1.4. And then finally, the only one that doesn't contain hydrogen is sulfur and chlorine at 0.5. Alright, so all we're going to do is just rewrite this in order from most polar bond to the least. So the most polar is going to be the one that has fluorine, because fluorine is the most electronegative, and so that bond is going to have the greatest difference in the sharingness, you can say. Right, so that's going to be the most polar, followed by the one that contains oxygen, because oxygen is the second most electronegative, and then followed by, what did we say, this was like 1.9, this was 1.4, and what else did we have up here? 0.9, okay, hydrogen chlorine. And and that had a electronegativity difference of 0.9, and then I believe it was hydrogen and carbon. Nope, sorry, I believe it was sulfur and chlorine. Sulfur chlorine bond was 0.5, and then hydrogen carbon was 0. These colors 0.4, and then finally the non-polar one, the one that has 0 difference, is going to be the hydrogen molecule, the H2 molecule. That's a difference of 0.0. Let me get these all